Hey everybody, in this video we are going to talk about how the cosine rule can be used with vectors and another thing called scalar products. So right now we already have a problem set up for us here. We've got vectors A and B, or OA and OB respectively. A is 3 in the x direction, 4 in the y, and B is 5 in the x direction and 12 in the y. And we want to find theta. So we need to find some angle. Now, based on what we have, we don't have enough information for the sine rule, but we could use the cosine rule if we knew the angle of theta, or if we could find the other side, AB. So fortunately for us, from what we know from vectors, we can find AB, and we can use the cosine rule that says that cosine of theta is going to be a squared plus b squared minus c squared over 2ab. So that's if we have all three sides. And here we already know that we have A, we have B, and we'll just use AB, vector AB, for side C. Okay, so first thing we need to do to find this theta is to find AB. And AB is going to equal the opposite direction of A. Because if we have to remember, we have to follow our path, right? So we have to go in the opposite direction of A. So that means we're going to have a negative A plus B is going to equal vector AB. Okay, so negative A, or AB, is going to equal negative 3, 4 plus 5, 12. So then we just add those together and we get 2, 8 for our vector, for vector AB. Now, the thing to keep in mind is that when we're using the cosine rule, we're talking about lengths. And this is just vector AB is just telling us the direction that it's going. It's not actually telling us the length. So we have to find the magnitude of these vectors in order to truly use this cosine rule. So let's find the vector of A, or I'm sorry, the magnitude of A. Well, that's going to be a square root of 3 squared plus 4 squared. Remember, this goes back into our magnitude formulas. So we just square those and start simplifying. Square root of 25, so the magnitude of A is 5. And we find the magnitude of B is going to be the square root of 5 squared plus 12 squared. And square those, we get 25 plus 144. Add them together, square root of 169, and the square root of that is 13. So we have the magnitude of vector B. And then finally we need to find the magnitude of AB, which is 2 squared plus 8 squared, and the square root of all of that. So we have the square root of 4 plus 64, the square root of 68, or 2 times the square root of 17. Okay, so now we've got our three values, our three magnitudes, or our three lengths, if you will, for A, B, and C. So now we can plug it into the cosine formula. So the cosine rule formula to find theta. So we have 5 squared plus 13 squared minus 2 root 17 all squared. And that's going to be divided by 2 times A and B, which is 5 times 13. So we have 25 plus 169 minus 68 all over 130. 169 minus 68 is 101 plus 25, 126 over 130. And we take, when we calculate that, we get approximately 0.9623. Take that from our calculator, right? So now we can find the inverse of cosine of that value to find out what the value of theta is. And theta comes out to be approximately 75.6 degrees. So there we go. We found theta. We can use the cosine rule not just in trigonometry, but in other avenues or other subjects as well. So now let's move on to this other thing called scalar products. And this is going to kind of tie in here a little bit as well. So a scalar product, it's sometimes also called a dot product. And this is when we have some vector A. So we'll say that, let's say it's going A in the I direction and A in the J direction. Now we got A1 and A2 on here, so that way it's signifying that it's two different values, but I want to keep track that it's going with vector A so we can kind of see how this is laying out. Vector B then is going to be B1I plus B2J. And what we're going to do is we're going to multiply these together. So we're going to take the we're going to multiply the two vectors together. So just like when we're multiplying a vector by a scalar, or if we are adding two vectors, we just take those values, those corresponding values, and multiply them. So we've got A1, B1 times I, or not times I, but A1, B1, I. A1 and B1 are multiplied together. I is just, again, signifying the x direction, right? We all know that. And then plus A2, B2, J. So multiplying A2 and B2 together. So another way that we can write this, if we're just talking about the values of these things, is A1, B1 plus A2, B2. Now, why is this significant? Why am I showing you this now? Well, let's look at our vectors here, 3i and 4j, and 5i plus 12j. So our vectors A and B from the previous example. So if we take these and we multiply them together, we're going to have 3 times 5 plus 4 times 12, right? So 15 plus 48, which is going to give us a grand total of 63. Awesome. Again, what does 63 have to do with anything? Well, it is going to seem like a stretch, but bear with me. If we take this thing and we multiply it by 2, what value do we get? We get 126. 126 should be significant from what we just did because it is the same value as the numerator of our the cosine rule that we are using above to find theta. So we can rewrite now the cosine of theta is equal 2 times the dot product of A and B. And that's divided by the magnitude, 2 times the magnitude of A and B. So when we simplify this, we get our cosine theta is equal to the dot product of A and B over the magnitude of A times the magnitude of B. Or if we wanted to rewrite this in terms of just the dot product, which is sometimes helpful, we can multiply both sides by the magnitude of A and B, and we get this equation here. And these two things are kind of key because they are kind of tying together the ideas of trig and vectors, and they're two very common formulas that we tend to use. So keep in mind that these can both work for both 2D and 3D vectors. So if we had a k value in there for our z direction, that would work as well. So kind of a cool idea that we can use the cosine rule in a slightly different way. I don't know, maybe you think it's cool. I think it's kind of cool. But let's take this and just take it one step further and see how some of the other identities that can come with our scalar products. Okay, so we've got our cosine rule. So let's say we are looking at, we're going to kind of build into some of these identities. We're looking at our unit circle, right? And we know that any point on our unit circle is going to have cosine theta for our x and sine theta for our y. If you don't remember how all this works, go back and check out our trigonometry videos, and that will help lay that out for you. So if we were looking at this value here, or this vector, that would be 1, 0, because we're on the unit circle, right? So from the origin to the circle is going to be 1, 0. And if we looked at this one, it's going to be 0, 1, the 90 degrees, right? So how does this tie together? If A and B are perpendicular, so vector A and vector B are perpendicular, then the angle between them is going to be what? Well, it's going to be 90 degrees, right? So the angle between two vectors A and B, if it's perpendicular, that means we're going to have 90 degrees. So thus we can say that cosine theta is 90 degrees or 0. The value is 0, right? So if we look at the point here, it's the cosine value is going to be 0, right? Cosine theta is going to be 0. So when we look at the dot product then, we have A times B is equal to the magnitude of A times the magnitude of B times cosine of 90. Well, we just saw that cosine of 90 is 0, so if we have a dot product of A and B equaling 0, then we know that these values or these vectors are perpendicular to each other. All right, that's kind of cool. What about if we have A and B are parallel to each other? Well, if they're parallel, then the angle between them is going to be 0 because we can lay them on top of each other, right? So it doesn't matter where they are, we can rearrange them, but they can lay right on top of each other, so there is no distance or no angle measurement between them. Thus, we can say that the dot product of A and B is equal to the magnitude of A times B and cosine of 0, which we have now seen is 1, right? Because that's the same thing as here, which is the value of 1. So our dot product of A and B is equal to the magnitude of A times the magnitude of B. And that again tells us that these things are parallel. So if you're working through a problem and you get either this or this, then we know that we can identify that the vectors are either perpendicular or parallel to each other. It's kind of a nice check. One last thing, and then we'll wrap this video up here, and that's if A and B are coincident to each other. And what does it mean if they're coincident? That means that B is equal to A. It's the same thing. So that means then we have the dot product of A times B is equal to the dot product of A times A, right? So the dot product of A times A is equal to the magnitude of A times A. Again, these things are coincident. They're the same thing. So the cosine value is going to be, or the angle between them is going to be 0, which means that this is going to be equal to a value of 1, just like a parallel line. So A squared is going to be equal to the magnitude of A squared. So some identities that come with this scalar product that might be useful for you. All three of these, including this one here, let's square that one off as well. All three of these things are going to help you out as you work through some problems and kind of helps you tie some ideas together. So hope this helps, and we'll talk to you in the next video.